question 6 of the worksheet, and it's taken from the IEB paper 2, higher grade, November 2000. So they say to antacids are medicinal bases that are used to neutralize excess acids, specifically HCl that causes indigestion. Some antacids, like Alka-Seltzer, cause effervescence or fizzing when added to water because the citric acid, and they give you the formula, reacts with the sodium hydrogen carbonate and CO3 2- from solution to produce a water and carbon dioxide. So they give us sodium hydrogen carbonate plus citric acid, and we get a whole bunch of stuff. So the first thing they ask you to do is to calculate the mass of the NaHCO3 required to make a 250 centimeter cubed standard solution of concentration 0.5. First thing I'm going to need to know is what the molar mass of sodium hydrogen carbonate is. So it's 23 plus 1 plus 12 plus 3 times 16, and we get 84. Okay, grams per mole. Now we're going to do the fact that concentration is mass, molar mass over volume. They told us that they want 0.5. We don't know the mass. We know that the molar mass is 84. 84 is about right. 85. That wouldn't have worked. And that's 0.25. So my mass, because you'll end up multiplying on both sides, so we have 0.5 times 84 times 0.25, and you get 10.5 grams. Okay? Nice and straightforward. Then they say what mass of citric acid would react completely with the 250 centimeter cube solution above. Here, when we have nitric acid, when we have an acid-base reaction, generally we want to try and do Na over Mb. We can't do that because I don't know the concentration of the citric acid. I don't know the volume of citric acid I used. So we have to go the long way around before, which means we have to start with working out the number of moles of sodium hydrogen carbonate that I have, which is why you just worked out the mass. Okay, so I have 10.5 divided by 84, and that gives me 0.125 moles. If I now look at my reaction, okay, first of all we need to check that it's balanced, and it is. Don't worry about that. Okay, it's a balanced equation, 1-to-1 relationship. So the number of moles of the citric acid, which is HC6H7O7, is 0.125 times 1 over 1. Okay, now if I want to know the mass, I'm going to have to do the fact that I know that the mass of the citric acid is number of moles times molar mass. I'm going to work out the molar mass of the citric acid inside the equation. You can do it separately because it doesn't actually matter. So this is 0.125. We have a hydrogen plus 6 carbons plus another 7 hydrogens plus 7 oxygens, and we put that all in our calculator and we get 24 grams. Okay? We good? Right. Now, sodium citrate is the sodium of a weak acid, citric acid. Will the pH of the sodium citrate be 7, slightly less, or slightly more? And then they want you to give a reason. So let's just see what happens. Okay, so I'm going to not put the answer. Let's talk through the reasons. Okay, when sodium citrate, so here, this is what's going to happen. The sodium citrate dissolves in water. Okay? It should be an S there. Oopsie. Dissolves in water. It forms Na plus ions and C6H7O7 ions. Now remember, it's a weak acid, which means it makes a strong conjugate base. That base is the C6H7O7. Okay? So C6H7O7 will react with water. Okay? It will then form HC6H7O7 plus OH minus ions. OH minus ions will increase. Therefore, the solution is basic. What does that mean about my pH? Okay, it's going to be greater than 7. Okay, because our OH minus ions increase. Okay, and the solution will be basic. And we're done with question 6.